and I hope you guys had your week too interestingly. And this time we will be going ahead with a very interesting session on object detection, as you may already know that. And we will talk about computer vision and the very interesting concepts around OpenCV, etc. Today, we will do some interesting code snippets in today's exercise, and then we will try to implement the complete solution in a short span of time, like we always do for most of our kids. But before we go ahead and discuss the concepts, we'll get onto our community page. So, as you all may be aware, that on your community page, a link would be shared in the chat where you can go for this Christ University Virtual Internship Program 3. And this is going to be our AI object detector, the use case that we were going to discuss today. And interestingly, first of all, I would like to congratulate you, all those who were able to submit their assignments, and they had also received successfully their week 2 badges. Should be received by most of you who had done their assignments. And also, apart from the badges, this week, this is our final week for the boot camp. We will also guide you today as to how you will have to do your final assessment submission, final project submission. So we'll discuss it after we discuss our object detection session for today. And for now, get onto this page. You know the ritual. You have to just quickly get ahead and get to your practical exercise part. Here on the practical exercise section, you have your one-click installer. This one-click installer, as we go and click on it, it takes you to the kit page. And this kit page, as we go down, under the deployment information, we see this one-click installer button. Go ahead and click on it. A zip file gets downloaded. We say show in folder. Extract the contents of this folder. Double click it. Double click the batch file. Say more info. Run anyway. So this will begin your installation process for your object detection. So by now, we all know that we can check out the progress here in the progress bar. And that's how your kit installation or your setup for your object detection should begin for all of you. In the meanwhile, I will minimize my screen and get back to the discussion of the concepts for today's session. So before we go ahead, I just wanted to ask you, do you have any specific questions that you would want me to take care of before we start today's session? I will also check the comments. So, all right. Okay, it's in relation to okay. All right. So it's specifically in relation to the badges. So let's get started. I hope how many of us are there in the meeting?
43, Pooja.
All right, that helps. So I think we should be resuming and actually discussing about our session for today. So we know that AI is a ubiquitous technology, and apart from just being any other technology, it is available or it is seen in every space or every sphere of our life. You see that as we talk about diseases, like we talked in our first boot camp for breast cancer prediction, we said that artificial intelligence could be used in it. Then it could, we saw in week 2 that we discussed on natural language processing concepts and we tried to use NLP to do fake news detection. So, as we talked about the different concepts in artificial intelligence regarding doing predictive analysis, or is it in natural language processing, or the topic that we are going to take up today, which will be on computer vision, which will be based on the different libraries which are available in computer vision. Artificial intelligence has already it's come into our lives, and we are already using it in different applications throughout, uh, let's say, not just for comfort and ease, but to actually tackle bigger problems. So there are algorithms around it, and we see that deep learning does play a very major role. So based on the neural networks that are being built, or algorithms which work based on the neural networks, which are similar to how the network connections are made in the brain, we are able to accomplish interesting outcomes. We are able to train models. We are able to expect the machine to be able to make decisions pretty much similar to humans after we have fed them with the required training. So for the training, we require the data and the model. So either you have that sufficient ample amount of data, and accordingly the expected response that you would want to generate, you train a model, and then that model behaves or takes up a new data and is able to get you to the expected outcome. So how has this been possible? Like, we have always talked about like, okay, AI can do this, AI can be helpful in particular application. But if we talk about the other technologies that have advanced and helped AI reach where it is today, so we'll have to take good consideration of cloud, the edge computing, and also the microcontrollers or the processing powers of a system, which play a major role. So today we see that we have Gen 10, i5, i6, sorry, i7, i3 processors, which are very capable of doing the training, which are capable enough to do a lot of image based training. And if the processing power of the computation that we are giving to our machine, that we expect our machine to quickly uh, give us results for, wasn't possible if the hardware, or this hardware backing with the processing power, with the RAM space, with the external memory wasn't possible. Because we see that even after artificial intelligence, there is generative AI, where you have large language models, right? Things have changed even beyond training a model on the CPU. We go to the GPU, and the GPU is some, a very, I would say, it's an architecture set that is able to help us do a lot of processing over the cloud. And that has been possible only with the invent of technology in the domains of cloud, edge, and microcontrollers. So when we talk about edge computing, we are not even pushing the entire code onto a cloud space, or we are not doing most of the computation on our thin clients or our local systems, but we are basically doing it at the edge of both of these, let's say, at the network space. So you do in edge computing, you do have servers that act in even between the cloud space as well as your system space. They try and do most of the computation as they get to a second server or a third server that is available over the network. And that way it tries to give you very quick responses to the required solutions. So talking about the relevance of open source, very important to understand that all these interesting solutions that we talk about today, and the growth that we see in the various domains, say cloud, artificial intelligence, blockchain, etc., that has been possible with the help and the availability of open source tools. So you see that we can reuse something that is already available. It helps us save time and effort. Also, if you see, you are able to get applications in all spheres of life. So only thing you need to check are the license requirements. Whatever you are completely taking for your own particular use, it should be under a permissive license. And because anything that you use in open source, it is being supported by a vibrant community of individuals, you are able to get quick resolutions to your problems when you get stuck while working around these tools. It is supported by OSI. And also, the interesting fact is that 90% of the world code actually uses open source. You can actually go ahead and check out so many repositories, code sets that are available on GitHub. and those are nearly around more than 200 million plus. And we have such 65 million developers who are contributing every now and then. Even you could be an open source contributor, just like these candy kits that you are tinkering with this week's solution that you developed today. I mean, the project work that we will give you, we want to keep it interesting, we want to keep it easy for you. You can actually also become an open source contributor by pushing your project onto the right space, and then letting people use it from your GitHubs, etc., or the Candy Kit that we will help you create. And I'll guide you after the session how you can create your own Candy Kit. So now talking about the concepts of object detection. First of all, the requirement for object detection is that we are instilling in machine the kind of capability where the machine is able to see, it is able to observe and understand. So when we say that the machine is able to see, observe, and understand, we expect the machine to be, to be able to do things just like us, right? We haven't before seen the machine able to get to this sense of human perception, where it is able to observe, and that's how the driverless cars are possible. Metros without the drivers are running every now and then already. If you go and check out in the Delhi Metro, there are a couple of lines where there is no driver. There's complete automated systems based on artificial intelligence and computer vision that is able to also detect and stop based on any obstruction that may incur into an accident. So what is required to create such a system? You require images, you require videos, you require a lot of data, and that data you feed into a model, and then that model is responsible for doing all your classification, detection, tracking. So all that classification, detection, and tracking that we are expecting as an application can be done with this intelligence that we put into our computer systems, or let's say onto our machines. We want to talk about object detection. So if you talk about object detection, it primarily consists of two steps. When I want to do an object detection, I will have to first do an image classification. First, I'll have to check what kind of image I'm actually trying to detect. Then I also have to localize whatever is present in the image. So two steps: image classification and image or object localization. So this image looks of people, okay, and a person's in the image, and then within the image exactly where the people or person are present, which is called object localization. So when you do both, and you are able to also classify the image and also able to localize objects within the image, then it is called object detection. And then you see on the right the complete process where a person has been detected with, say, 0.69 confidence score, another person with 0.61, and similarly a person three with 51% of confidence score. So what's the process of object detection? If you see, initially there is an input image, and these images are used as the data set that through which the different features of the images are extracted, and a feature map is being created. Based on the feature map, we use the different features in an image to train a model, and the model then tries to enhance these features in a way that it is able to suitably discriminate amongst the different images based on these features, and that is being passed to the backbone of your neural network. So a neural network is what is used to train your input image. I mean, multiple such input images are used, and then your neural network is created, and the backbone basically forms with the different features, and your head of the neural network is what is responsible for making the prediction. So what are we intended? We are primarily intended on enhancing the features in a way that we are able to discriminate properly between two images and two similar sort of images, and discriminate based on the different feature maps that is being created while doing the training process. So this is the entire flow in which your object detection neural network will work. So what are the different algorithms that are available or what we are going to use today or what was used in the past? So in the past, there was RCNN, there was SSD, single shot detector, there was this recurrent convolutional neural network. But then today, if you talk about today, our model for today would be YOLO, which is you only live once model. And even that, we will see that how this model is pretty different and fast, that we are able to do real time webcam feed capture. So today I'll be able to actually showcase you how in real time the webcam will be able to detect objects using the you only live once model. Sorry, you only look once model. So the name is so interesting that it does confuse as well. So talking about what used to happen previously, just like in an operating system used to submit processes in batches. Similarly, the image had to be scanned from the top to the end, top left corner to the right end corner, and the system was pretty slow, that we didn't had the right processing power, and to be able to identify something within an image, that entire image had to be scanned, and it used to take a lot of time from one end of the image till the top left corner till the right end corner. The scanning had to be done. So these bounding boxes that you see are basically helpful in detecting the objects. And if we talk about the single shot detector, it was a better version of the RCNN, where a continuous sensing, continuous image sensing had to be done, where your entire image had to be scanned, your pass had to be performed from one end of the image till the other end, and that used to be a tedious process, and it used to not happen in real time. But then slowly gradually there came your SSD, where a little bit improvement happened. Your single shot detector was pretty much far better as compared to the RCNN, but yet it could not give you real time object detection capabilities. Hence today we will talk about YOLONet. Retina net is also there, which is again an interesting model, which works on creating bounding boxes around the images, and the more the image is present at a particular region, the fatter is your bounding box. The same scanning, continuous scanning happens, and then after that particular portion has the more fatter bounding box, we are able to locate, let's say, this dog, this bicycle, as well as a car in the background. So important thing to note or to be used is that this continuous sensing should result in a real-time feed capture, or should be able to remove the unnecessary noise, whatever noise may occur while this bounding boxes are created, right? Correct prediction requires noise suppression, and also it should be effective in the blurred and low lighting scenarios. If the image is blurred, or I mean, it's not a very high pixelated image, then also it should be able to detect objects within the image. Talking about image augmentation for training data. What is image augmentation? So you know that I want to do object detection. So depending on the images that I have trained my model, it will be able to detect those sort of images and not anything apart from that. But I have to prepare the data in a way, right? How do I prepare? How do I label the data? So I'll need some flipping that needs to be done with the image. I may have to rotate the image. I have to scale in, scale out the image, zoom in, zoom out the image, such that whatever kind of image it is. So the same image needs to be into various forms before we use it for training. You have to adjust the quality if it is If it is a high quality image, then you have to also go ahead and get a similar low quality image. You have to add noise from your end. You have to blur the image from your end and then pass it across through your training data set. That way, your model will be trained perfectly to identify images which are on low quality, which are having some noise. And depending on the size, zooming, rotating, flipping, etc., also it is able to properly based on the position. It is able to give the object detected within an image with a certain confidence score. So there are some popular data sets and the formats that are already available. One is your COCO, which is your common objects in context, and Pascal visual object challenge. These are the two types of data set that are available. One is in a JSON format, another is in your XML format. So what is the difference? When you have all the images consolidated in a single file, then you go ahead and you're saying that this training or the model has been trained on a COCO data set. And the bounding boxes that this COCO model, data set helps produce will have images with four parameters X, Y, width, height. Similarly, for Pascal, there is a separate file per image in the data set. So this is somewhere different, completely different, Pascal and COCO. And the way the bounding boxes are drawn in Pascal, they will have parameters as xmin, ymin, xmax, ymax. That is how, xmin and then your ymin, xmax and ymax. That is how they are able to draw the box around the particular image within the, sorry, particular object within the image. So now let's go ahead and check out our solution. By now you should have reached here. All right, you just say yes and enter. So this will open your Jupyter notebook automatically for you. So once the notebook is open, this should be your notebook. I will just have to close the video since I will be using it using the camera to showcase you the results. All right, sorry. Yeah, this is our kit. So this kit should open for all of you by now. And then you just say restart and run all so that your kernel is able to load the outcome as well. All right, so let us understand what is happening in the notebook. And we will also do interesting code snippet exercise as we discuss the solution. So, okay, this is your solution source. First of all, we have imported our NumPy library for all the mathematical operations that are required to be done. Then you have your CV, your OpenCV library that is being imported. Further, we are using pathlib for locating the path. And then for displaying the image, we are using your ipython.display. And torch is again, PyTorch is again used for all the machine learning operations. So we will all use a pre-trained model, right? We don't have the capabilities that we are able to train the complete model onto our own machines. So from torch.hub.load, and Ultralytics is the name of the organization which has created the YOLO version 5 model. We use this model, load it into the variable called model, and then we pick up a common image from Ultralytics itself website. And then this is the image. We want to locate people, or let's say locate the objects in this image. So when you run it, we are just printing and also showcasing the results here. Just in case if you any one of you get an error, just copy this path. After, copy this path here and then add zden.jpg. For maybe any of you, if this error comes, just add the path of the file name here for the display. So what is happening in this image? This image basically is able to state two people and even their tie with a confidence score of 88% and 67%, as well as one person's tie with a higher confidence score and another person's tie with a lower confidence score. So that is how this object detection pre-trained YOLO version 5 model is running. What we've done, we want to also capture our live video frame. So I will just need my taskbar here, and you could see that it is also able to state that it is able to say that I am a person with a decent confidence score. Let us check what else it can detect. I have a cup. So this model is also trained to identify a cup. So depending on the position, right? This is all real time. Why would I say as I am moving, it is clearly able to put the box around the image. You see, object and also label it as cup with a certain confidence score. Let's check something else that it will detect. Let's see. It's saying that it's a spoon. Here, spoon with some 50 or depending on the position and the stability, it is able to state that's a spoon. What else? Let's also check whether it can discriminate a fork and a spoon or not. See, it's calling it a wine glass. So it depends on the accuracy. So when I move it at the right position, it is able to identify it as fork as well. That too with 78 and 75% of probability. What else? Let's check. So it's not been booked on a book, or else it would have, but it has been successfully trained on a motorcycle as one of the components. And hence it is able to state the motorcycle within this notebook itself. What else it can identify? Can it identify? It's able to identify the keyboard as well with some 84% probability. So could you see the power? What else? Let's see. Hmm. Bottle it is able to identify. Let me check this last component. It knows it's a cell phone, right? So yeah, if we see that this object detection model has been able to actually identify a lot of objects. With this, get back to the code, right? So what we are doing, we are saying with the CV2 library, we are trying to do a video capture, and within the loop, we have read whatever we have read through the video. We are reading it into the two variables RETN, image NP. Then on our image that we have read from this video, we are applying our model and showcasing, I mean, storing the results in the results. With the results.pandas, what we are doing, we are creating a data frame of our results, converting it into a dictionary form, and reading two. I mean, within the dictionary, we want two things. One is your confidence score, and another is your name or the label. Okay. Let's say I was able to state the fog with a certain score and also give it that label called fork, right? So the name dot values and confidence dot values is then being stored in the scores and labels. Further, what we are doing with the item that has been, dictionary, we are trying to iterate the dictionary for records, and then because we want to draw the bounding boxes for every item, we are looking for a rectangle box. We see that x min, y min, x max, y max are the parameters that we have used. So based on the parameters that we have used for bounding boxes, we then store it into the image underscore np, and we also let the general parameters be, let's say, thickness of the bounding boxes too. If I increase it, then obviously the outer boundary would be a bit more. The color dimensions we've kept it to 255 comma 0 comma 0. And similarly, the labels that we want to showcase, right? We want to also showcase, I mean, whatever has been the count, the confidence score, etc., of that particular image, that also we are trying to locate here. Then comes in, this is for showcasing the IM show, your particular the window in which we were seeing the object detection. So that will be this window. And we have also it's just created a if loop that if a Q is being pressed, then the window will exit. So yeah, This is your model that should have come onto your systems by now. How many of you are able to do real-time object detection already with the kit? Able to set up the kit? So Gajula, I would like to answer your question that why it has not detected my spectacles, nose, hair, a lot of things. So basically, whatever data items it has been trained on, only those it will detect. Okay. This is the YOLO version 5 model. Nearly some 80, 85 or 90 objects it has been trained on. That's it. So not everything it will detect. Okay. What else? Any other questions? It will be really nice to go ahead and tackle some of your questions that you may have. Gajula, was your answer? Were you satisfied with the answer?
Yeah, yes.
All right, all right. Any other questions? Any other questions? So depending on even in this image, if you see, it could have detected the person's hand separately or a shirt also separately. So only things it has been trained on, it will detect, right? I expect a very good question from all of you. This is a very interesting kit. I really like the kit. How many of you are able to set the kit onto your systems? Can you please use the raise hand feature to acknowledge and let me know? Okay, quickly we will check all of the people. Anyone who is able to not run the kit, you just have to set the path. I have mentioned that part. 12 of you. See, in case you may feel it may not have been, only for some systems it happens. Just copy this, the path and put it across here and just give the name of this image. Okay, so 16 of you. What about the other 30 people? Let's say nearly 28 people. All right, 18 of you. People are getting disconnected and connected again. Okay, so Adil, just do what I have just mentioned. System cannot find the path specified. You have the Jupyter notebook open, correct? Can you, Adil, unmute yourself and speak? Thank you.
No, ma'am. I get this error from
You get this error from
command prompt.
command prompt itself. You
Yes.
are on a Windows system itself, correct?
Yes.
You
Ma'am,
extracted it.
do you want me to share the screen?
Okay. You can share screen. Sure, I'll stop sharing. Okay. So a valid system, the system cannot find the path specified. Let us go to the log files. You followed that same process, Adil, right? Extract C drive, Adil. You
So it's
need to
the same
clean
issue,
up.
right?
Yeah,
All
yeah,
right.
yeah.
All right, ma'am.
Clean it up. So clean it up. You need some space so that the model can be downloaded and then you can use it.
Okay,
These are
ma'am.
all heavy models. Thanks, Adil. All right. What else? What else? What else, guys? Let's do some simple coding exercises also. Wasn't this a very interesting and simple solution that we worked on? Let's get back and on the community page, you should be able to check out that there are 3 simple sample exercises. By now, you guys must have become smart enough to actually use Candy. So let's go on Candy and make searches. First of all, the first exercise is make an image blurred using OpenCV. So that is the keyword I will use here. And I'll hit find. Go to the code snippets. We'll check that this third one looks simple and easy for me to run. Go back to my notebook, say file, new notebook, paste the code here, and then I'll have to look for my folder, correct? Let me also get to my folder. The git installer folder. All right, here I would go to the C. I actually have it real-time object detection, and I just have this image. I can just use the Zidane JPG, the image that we are using to, yeah, this image I will use to blur it. Okay, so I'll just say Zidane, and I do have an option if I just go ahead and I can look for other sorts of blurs as well. Currently, this is a repeated code. I will remove the bottom one. Just few simple lines of code. And I say Control Enter. And I believe blurred image is being showcased here. And let's see this is the blurred image. Let's see the original image. So this is the image and this is the blurred one. All right. Then we can also do another coding exercise. Okay, which is convert image into grayscale using OpenCV. So again, I go here and say convert image into grayscale using OpenCV and hit enter. I go here, let's see this very simple code snippet. I pick this one, this looks relevant to me. This, let's go here, paste it. Let's read that same image. It was a JPG one, so I'll change the JPG. Roll enter. The first one is still running. I'll have to close this. And then I would see that a grayscale image is showcased here. So you can do the similar, just follow some very simple steps and do grayscaling using OpenCV and do blurring of images using OpenCV. And yeah, again, Candy could help you do really interesting and simple exercises with such code snippets that you can find onto the platform. All right. So apart from this, talking about the submission today, uh, how would you submit the project, right? How would you submit? So for that, let's get back to our page. Usually used to find a assessment button here. So now since it's your final project completion, we will send an email to you when it will get activated. And as we send the email to you, we will also share information. Let me close this particular image as well. All right. Okay. Yeah. So we'll send you information on how you can start working on the solution. This time we want you to work on we're going to give you options in different domains. Let's say you can create your own project. You can find your solutions on GitHub. Maybe one of you can create a disease predictor. Any other can work on some NLP concepts. Someone can, do, let's say, crop prediction, crop disease prediction based on the breast cancer kit that we had done. Or, just like fake news detection, where we were able to do binary classification, you could work on some sentimental analysis, classify a particular sentiment as positive, negative, or you can also put a third category called neutral. So we leave the complete you know freedom to you to build a solution in artificial intelligence. You can obviously use open source. So check out the repos that are available on GitHub, download one of your own. But how do you submit your solution? So to be able to submit your solution, guys, you'll have to create a kit like this, not a one-click kit, but a simpler kit of sorts. So I'll tell you how you have to create a kit with the same account that you are on. Go on to the Candy Kit. I will just say I'll just use this. Then I'll say explore. So the interesting part is when I want to create a kit, I can simply just go and click on this MySpace. And in the My List, you just see once you are signed in here, click on Candy, you just have to click on the MySpace. This will take you to a space where you can create your own kits. Here, go to the My List, click on this plus icon. This will create a new list for you. In this new list, you give a name for your project. So let's say I would give, first of all, my name and then space or underscore. Let's say I want to build the same kit for object detection system. So do follow this very nicely, guys. Object detection system. And here I have given the heading, my name. I can tag it under the category computer vision. I can also tag it into artificial intelligence. All right. You can also add it for this library called PyTorch, OpenCV. All right. I can just add tags, right? If someone is searching my kit, you have to create your own kit as a submission. Next step, what you have to do, you can add the description for your project. So I've kept this ready, right? Let's say I'll just add a description like this. Here in this box, I will just write it in capital, but this is the description. I will just make it bold. I will make it a heading one. No, let's say a heading three. And then whatever I have put in here, if I want, I can also add an image, right? I can also add an image like this. So I'll pick up this save image. Maybe I can copy and paste it here. Yeah, so I could copy and paste it from that word, or you can use this to check out a particular image and add it if you would like, right? Talk about what your solution is. You can say, I will remove using this Candy Kit. So you don't have to create your own one-click solution, but you just have to give description that you have created, let's say, diabetes disease prediction. Okay, so you would say diabetes disease prediction is a system that will help in analyzing whether a patient is having diabetes or not, and using binary classification here. And then you give out some details, some image if you would like, you would want to add. So first section of your kit will be description. Okay, after you have named it with the name of your kit, and let's say whatever system AI system you're building, you can add an image icon. Maybe I would choose this one. Okay, we can choose any of such icons. I'll just redo pasting it. So you saw that that thing got evaporated a bit. So just click on this save button here. Okay, just click on this this does auto save, but it is better if we click on the save button here and then click enter description. bolding it, setting it to heading 3. Then after that, I will add another section. What the next section would be after I have done this, I want to now add libraries. What libraries did I use in object detection, guys? I used the most famous library, OpenCV. I will just search it here, hit on find, click on libraries, and then choose a library which I feel is relevant. I will remove this TensorFlow and whatever filters that were available. So yeah, OpenCV. This is coming by OpenCV itself. Maximum stars. So I'll just add it for now. What else did I use? I will say PyTorch. Okay, why not? So I'll just go and say PyTorch and click on this save. This gets into my space. Okay, this gets into my space. I just am collecting these libraries that I want to add to my kit. So just save them here from by clicking here on this heart. Just save them into your MySpace. What else? I want to add the development environment that I'm using. Let's say I am using your Jupyter notebook. Again, I hit enter. Go to the libraries here. Jupyter Hub. Let me just call it notebook. Yeah. So notebook by Jupyter is what I want to save. So I will save that one as well. So I'll get into my space now. This is something I may have added before. I will add my OpenCV, PyTorch, all these three. Go up and say move to, which is my list. This is my project list. I will select and say move. After I have moved it, I'll go back to my list. I see my MySpace is emptied of the three. Then I will create a section called dependent. Follow this very importantly. This is how you'll have to submit your solutions, okay? Dependent libraries, bolded. Let's keep the heading 3. If you want, you can separately move this up and add another section, say content editor, and bring the content editor also up. Here and it went up. Let me put instruction as development environment. Okay, bolding this, putting it to heading 3, getting it one level down. So, I just have the description, then the development environment, then the dependent libraries. Okay, so basically one section is description. Second section is basically the libraries and maybe if you would like the environment that you have used to develop. Then third is the most important section, right? What is this section? This is your GitHub repository link. Okay, just bold it, say heading 3. So what you got to do, you need to upload whatever solution you develop on your GitHub account. Okay, right? So this is my repository. You just know how you can push your code here. You can Google it, check out a video as to how you can push whatever you are developing. That way you will also have it live for everyone going forward. Once whatever solution you develop, tinker with it a little bit. Copy this link, paste the link here, paste this link. Okay, so very important to paste it as a hyperlink. Okay, just click on this, enter the link here, and then save. So then it will be something that we will use to evaluate the solution that you have submitted. Okay. Again, I add another fourth section, right? Section 1 was description. Section 2 was dependent libraries. Section 3 is your GitHub repository. Whatever solution you have prepared in the Jupyter notebook, that link you have to give us here. And the final section is your solution. Right? Solution source, screenshot. So while I was demoing with you, I have my screenshot here prepared. Right, you can also mention different things about the development environment, right? If you could like just put the text in the development environment, you just put the text here about the development environment, save the kit from here. Then in the dependent libraries or all of that, you can mention you have libraries in image processing, you have libraries, you can make it as interesting as you want, right? You can make it as interesting as you want. Copy paste these details here. Library is already there. Then this is your solution source. I had captured this image. So I will just add the screenshot of the code and of the code as well as whatever is the output. So your one of the projects could be even object tracking, where you will just have your boxes, no labeling would be there. One of your projects could be any project in artificial intelligence. We would like to see how many different solutions you guys submit. Okay, so I saved it, changed the image. This is very important, the name part. Tags is all okay. As I click on publish, as kit publish now, wait for a couple of minutes. A link for your kit would appear. See, view your kit. So this has become my kit now. You can give this to anyone, any of your friends, and you can actually make it more interesting, right? Add an image. I will edit it. I added the dependent development environment, dependent libraries. I added this GitHub repository link and also the screenshot. You can see how nicely it is being showcased here in the kit. I've just created it in front of you. Now I will just edit it because I know I want to change something. I'll add an image here as well, just to make it a little bit more interesting, colorful. Uh, okay, where is the document? Yeah, here I'll just use the same. I mean, you can use any image. Just copy paste the image here or use this upload feature to upload an image. Save it. Once again, publish as a kit, publish now again. Wait for this link, click on it. See, look at this. So the image also appears here and it sort of looks like a. So this is going to be how you will have to submit your solution. So this link is what you will give us in the Google form. Is that okay? Guys, are you able to understand? We'll also provide you a video without an audio as to how you can create your own candy kits. You can check out this same video that I have just recorded, I mean, this session video to create your own candy kits. Any questions? Any questions, or is everything clear regarding how you will have to submit the final project, your final project for the internship? Is it clear, guys? Clear, not clear, anything? Yes or no? You can put it in the chat. clear. All right. Like, thank you. So yes, that's why I had to take it really slow. So this is primarily how you will do your submissions. Any questions that you may have for the kit? Were you able to run the kit, guys? Okay, okay, okay. So awesome. Thank you. So I think this is it from our end. You will receive your badges. Whoever hasn't received the badges, you've already mentioned it in the chat. So we'll take care of that part. Apart from that, you already know the process. If you have any queries, go on to the page and yeah, go on to this page, put in your queries using the reply option here. So for replying, you need to be logged into the platform. Okay, nothing else. Okay, so I think this is it, Sandhya. Over to you.
Thanks, Pooja. So students, I wanted to inform you that a follow-up email will be sent today, which contains all the essential resources, including the project assessment that you need to complete, etc. So therefore, I kindly request you to check your inboxes promptly. If you're having any doubts, please ask now. Sir.
Yeah, very important. If you have any doubts in the submission, you know this candy kit creation is very important. And also this way your solution will be available, you know, every time to you, as you can, you know, use this link. And the same we can also check. So how you upload it to GitHub is something you can just use Google and check. Very simple process. So okay, thank you everyone, and I hope your the solution for today seemed interesting to all of you.